Well, this presentation is all about Rutherford's atomic model. I am Sulagna Das, senior lecturer from Math and Science Department from Jharsuguda Engineering School. In this video, I am going to explain the experiment conducted by Rutherford, the observations and interpretations made by him, and the postulates proposed by him. So let's begin with the experiment. In nearly 1911, Rutherford discovered nucleus by performing an experiment which is famously known as Rutherford's gold foil experiment or Rutherford's alpha ray scattering experiment. In this experiment, he directed a highly energetic stream of alpha particles from a radioactive source towards a very thin sheet of gold foil of nearly 100 nanometer thickness. In order to study the deflection caused to the alpha particles, he placed a fluorescent zinc sulfide screen around the gold foil so that whenever the alpha particles will struck the zinc sulfide screen, a tiny flash of light will be produced. So let's see what are the observations. So from this experiment, Rutherford was able to particularly make three observations. The first observation was most of the highly energetic alpha particles passed straight through the gold foil undeflected. Second, some of the alpha particles were deflected back through large or small angles. And third, a very small number of alpha particles were deflected backwards. That means they are retracted back in their path. So from all these observations, he was able to interpret a few conclusions also. So the first observation that most of the alpha particles travel straight through the gold foil undeflected, which means most of the space in an atom is empty. Second, some of the alpha particles are deflected by large or small angles, that means either acute or obtuse angles. That means the nucleus is positively charged as the alpha particles, and the deflection must be due to the enormous repulsive force present inside the atom, and that positive charge in an atom is concentrated at a particular small volume. The third observation, occasionally an alpha particle travels back from the foil. That means a very few alpha particles, nearly 1 out of 20,000 alpha particles were retracted back in their path. That means they are deflected in 180-degree angle, which means the nucleus carries most of the atom's mass and the volume occupied by the positively charged particles inside the atom is very small as compared to the total volume of the atom. So from all these observations, interpretations and conclusions, Rutherford was able to propose his nuclear model. So let's discuss the postulates of Rutherford's atomic model. The first postulate was atom consists of two parts. The first one is nuclear part consisting of nucleus. Second, extranuclear part involves the electrons. Second, nucleus is an extremely small positively charged particle due to the presence of proton, and it is situated at the center of the atom. The whole mass of an atom is concentrated at the nucleus only. The fourth postulate, the electrons revolve around the nucleus with very high speed, just like the planets revolve around the sun. So they are called planetary electrons. Number 5, since atom is neutral, the number of protons is equal to the number of electrons. Number 6, the diameter of the nucleus is nearly 10 to the power minus 13 centimeter, which indicates that the size of an atom is nearly 10 to the power 5 times the size of the nucleus. And number 7, the extranuclear electrons revolve around the nucleus in circular paths known as orbits, and the centrifugal force which arises due to revolving of electrons in the circular orbits is balanced by the force of attraction between the nucleus and the electrons, which prevents the electrons to fall into the nucleus.